Hi guys, so today I have with me problem 4.17 from Young and Freedman's University Physics textbook. Let's get started. So this is a pretty simple question, but I really can't tell what you guys like in terms of content and what you guys don't like, so I'm just going to try everything. Okay, all right, so Superman throws a 2400 Newton boulder at an adversary. What horizontal force must Superman apply to the boulder to give it a horizontal acceleration of 12.0 meters per second squared? Okay, so first let's just write down all of our knowns. So knowns, there's going to be, this is the weight of the boulder, right? So FB, right? So actually I should say like the weight of the boulder. Yeah, okay, let's just say FB is equal to 2400 newtons. And that, okay, actually, let's not get into that first. And we are looking for the horizontal force. So force applied is equal to what? To give it a horizontal acceleration of 12.0 meters per second, right? So to give the boulder, so acceleration of the boulder should be 12.0 meters per second squared. Okay. So now let us draw this out. So just some dude flying in the air, some cape. Okay. And he has this boulder, and the weight of this boulder is 2,400 newtons. And he wants to throw this so that the acceleration is equal to 12.0 meters per second squared. Well, really, what we're looking for is the horizontal force, right? And the horizontal force is going to be the mass of the boulder, right, times the acceleration of the boulder. So we have our acceleration of the boulder, and mass of the boulder we don't have, but what we do have is this is the weight of the boulder. And the weight of the boulder is going to be mass times gravity. And we know that gravity is equal to, well, this is going to be mass times 9.80 meters per second squared. And we can just isolate for the mass, right? So if we have FB is equal to mg and we want m, then we just have to do FB divided by g is equal to m. And that is going to be 2,400 newtons divided by 9.8 meters per second squared. And that is going to give the boulder a mass of 244.9 kilograms. And so if that's our mass, we have our acceleration. We just need to see what's the applied force on this boulder. And that's going to be 244.9 kilograms times 12.0 meters per second squared. And FA, or force applied, is going to be 2,938.78 newtons. And just with significant digits, that's going to be 2,940 newtons. All right. Sorry, my handwriting's super messy, but I hope that's all right. So 2,940 newtons. Thank you so much for watching. If this was helpful, please don't forget to like and subscribe, and see you next time.